Hello, at the beginning of the week I decided to take this attenuator out of the old Moog synthesizer and work on it a little bit because it's a handy little circuit. You send a signal in here and you sort of attenuate it and you get a signal out of there. Nice and simple, completely passive, and yeah, it's useful, but it's very limited. So what I decided to do was make a little circuit board and make an attenuverter instead. Now what an attenuverter does is it takes your signal and it actually flips it over. So your positive peak becomes a negative peak, your negative peak becomes a positive peak. So you can attenuate down to 0 and carry on all the way, so you're flipping a circuit 180 degrees. And brilliant, yeah, I kind of worked on the breadboard and I got a little circuit together. So the attenuating inverter, or the attenuverter, is just this tiny little bit of a circuit here. What it does on the screen, if I send in a triangle wave there in the yellow and a sine wave there in the green, then I can go up and down and take it to 0. And that is doing the same as what this does. But this doesn't require any circuitry. But that's as far as you can go. Now, if I want to get that sine wave and go to 0, I can carry on. So I'm flipping it upside down. You see, this now, this peak, goes to 0 and carries on all the way up that way. And the same with the triangle. I can flip that one upside down as well. Sorry, these potentiometers keep dropping out of the board, so it's a bit messy. So there you go, that part of the circuit was done. So after I made this nice simple little circuit, nothing to it, just a dual op amp, and there's the little trimmers on the back and everything. Yeah, looks sweet, but it's simple. It's just sort of that expanded to this, so I can invert the signal like so. That's done, that's great. But before I decided to work out the circuit diagram and print it and actually make a proper board for this, I decided, hang on a moment, I might want to do something a little different with this circuit. So I added a couple of bias adjusts. Now what the bias adjust does is, if you look at the green signal, I can actually add a bit more voltage to it and lift or lower the actual signal, and do the same with the triangle. Now this is moving from side to side because the oscilloscope is actually using this point on the triangle as its trigger point, so the whole thing will move. So now what I can do, if I get the sine wave like so, and I want to lift it from this 0 point, that line in the center is your 0. So this is a plus voltage and this is a negative voltage. So now I'll be able to send in, say, a square wave or something and actually move it up and down using the bias. So if I just get the sine wave and I move it up there, that means I can send a signal in and then shift it upwards. So this now will be 0 to 5 volts. That's handy for things like gates or triggers. I can make it 0 to 5 volts. So now what you can do is I can bring a square wave in that crosses the 0 point. This along the center is the 0 point. So anything above this point is a positive voltage, anything below is a negative voltage. So if I wanted to make that 0 to 5 volts, because this is minus 2 volts, minus 2.5 to plus 2.5, now what I can do, I can use the bias adjust and just lift it there. Now this is a 0 to plus 5 volts. That's handy. Or 0 to minus 5 volts. And also invert the signal the other way round. So if I have a signal of 0 to 5 volts coming in, I can make that 0, the 5 volts, and I can make the 5 volts into a 0 simply by twisting the signal the other way around, like so. That's also possibly handy. I don't know, might make a handy tool for the Euro racks and things. I know these things already exist. People have already made these things anyway, but it could be handy for something. especially if you use it with audio signals. But at least here, you can use that as a gate signal. So if you've got a gate signal that's coming in as just a square wave, then lift it up so it's 0 to 5 volts, and then invert it the other way round. That's handy. So I've added that part of the circuit to it. So the attenuverter, no, I'm not going to proceed with that. It's 2 channels and it attenuverts, and after getting that far I decided, no, I want to add the bias adjust. So that one's in the bin, and along came the new circuit with bias adjust as well. Brilliant. So after sitting for a while and trying to figure out the circuit for the bias adjust instead and making it all into a nice little package, I carried on experimenting. I thought, no, it's still not good enough. There's lots of other little handy circuits that I could add to this. So you've got your op amps, and this is your, let's say, this is your potentiometer here, and this is your signal input here, and this is about 4.7k. I'm going to put all this in a link somewhere anyway. There's your ground, this is your signal input, this is a potentiometer of about 50k. I think I used 50k's on there. And this is your minus, and then I believe this is the trimmer. That was another 50k pot. That's those little trimmers, but I don't need to use those because I'm pushing this further and further. And this is a 50k resistor, and this is your output. That basically is your attenuating inverter, attenuverter. All right, attenuverter. I don't know if that's an E or an O, supposed to be, who knows. So you've got 2 of those. Then you add the bias, which means sending in a bit more voltage to shift it upwards or shift it downwards on the output. But there's so many different things you can do with these op amps. Now, I could add maybe this circuit. Put a 1k in there to ground. Have an output here, and I'm going to mess this up, aren't I? I think this is a 10k, and if we put 10k here and 10k there, basically this circuit now becomes a summing circuit, and you can keep adding more of these 10k's in here. So you can have input 1, input 2, input 3. This is how a simple mixer works. This is your output. So you're sending in signals here, and this mixes them all together and gives you the output. So yeah, why not do that as well? And then I could add another bit to the circuit. How's about, instead of mixing the 2 signals together, how about the difference between the 2 circuits? So you add a difference amplifier now. So this is a summing. So basically it's V1 plus V2 equals the output that comes out of an op amp. But a difference circuit, it works a little bit different. Now that would go into the negative here, positive. So this is in 1 and this is in 2. Need a resistor there. Let's call them all 100k's. Doesn't matter as long as there's the same values basically. And then 100k down to ground here. So what this will do now on a difference circuit of an op amp is if I send a voltage in, say that voltage is 1 volt. So input 1 is 1 volt. And say if I put 5 volts in the input 2. So input 2 is 5 volts. Okay? What this is going to do, this is going to take voltage number 2, which is 5 volts, and that's going to take that away from voltage number 1, which is 1 volt, which equals 4 volts. So now I should get 4 volts out of here. If I'm sending 5 in there and 1 in there, I'll get 4 out of here. Now, it doesn't sound too exciting, but if you're doing this with moving circuits, moving signals rather, then you can start getting some interesting signals coming out of this side. Now then, on top of that, I can also invert the signals of the sum and invert the signals of the different circuit as well. So that what you're sending in here, it's also going to send out a plus 4 volts from that circuit, and then it will invert it and send out a minus 4 volts as well. And here, if this adds, say, your 1 volt and your 5 volts together, you're going to get 6 volts out of there. So this is your output for 6 volts. Add an inverting circuit, and it's going to give you a minus 6 volts. So it starts to get really complicated. But it isn't really, because these are just operational amplifiers. And operational amplifiers are used in so many things. If you look in just about every synthesizer ever made since the op-amp appeared, there's op-amps in there. And so, anyway, long story short, I carried on with this circuit, and I've put a summing circuit on here to sum these two signals together, and also a different circuit as well. So now things should start to get more interesting. Now I've added the summing circuit and the different circuit, because the summing circuit is going to add together the two strange waves, and the different circuit is going to take one from the other. So it will take signal 1 from signal 2, or if I go through the inverting circuit, it's going to take signal 2 from signal 1. I know this sounds complicated, but it's the end result that matters. Now on the oscilloscope here, if I bring in the other two signals now, this is where things start to get interesting. Turn off the, just to make it easier, turn off the original inputs. So you can see now that I can start to make strange, sort of different kinds of quirky shapes. I don't know, that could be quite musical. If I now get channel A and turn it into a sine wave, you start to get these really strange, wonderful patterns. And it's these strange, wonderful patterns that can help make quirky sounds on your synthesizer. I mean, I haven't really had much time to sort of go through all the different shapes and patterns that I can make out of this. But from this point on, I decided, call it a day, stop at that, and start making this circuit for an actual circuit board. And then I can always add to it at a later stage. That's enough for a little module, I think. To be able to get patterns out like this is good enough for me. So somewhere you have to draw the line and say, right, get on with it, make it, because already I've spent days working on this. So if I'm not careful, I'm going to need this many pots, potentiometers, just for a little project, basically. And it's going to take up too much space. So I've drawn the line. That's it. I'm going to make this. I drew all the circuit out off here, and then that has to be translated into a circuit diagram. I know there's programs like Fritzing and Eagle and things like that that can help you out, but I wanted to do this as much the old-fashioned way as I possibly could. That's the way my old-fashioned brain works, basically. The board didn't quite work out the way I wanted it to work out. There's a couple of little things I could have changed to try and make it a little bit better. So what I've done yesterday, which is the same video but moving forward a couple of days, is I've remade the board. This is the board just here, you can see there. Looks similar, but I've done a few changes on the other op amp up in the top here. So yeah, brilliant. That's the sort of original, and this is the piece that I'm left with now. So this, I could still use some of the ideas off that, and I made a couple of mistakes as well. I actually made the track incorrect just here, so I had to re-drill some holes and extend the resistors, and I thought that was a bit messy, so I remade it. Anyway, the important thing is it's working, it's doing things. Basically what I've got going inside here is the yellow and the green are the two signals being inputted into this, and one of them is 5 kilohertz and one of them is 5.00005 kilohertz, to give you that sort of nice bit of emotion type of thing. So playing around, I've got a kind of a different circuit and a summing circuit type of thing, and they're being fed back out to the oscilloscope. So if I turn this this green one off and that one off, this is the kind of pattern I'm getting out of it with just two triangle waves. And I don't know, that could be useful. I mean, I really don't know, because this is just purely experimental. It's just me messing about, trying to make a module that could possibly be useful on a synthesizer, whether it be an audio signal or a control voltage or something like that. So yeah, so now I've got this kind of pattern, and I can sort of do a lot of manipulations. I can sort of twist it to the right at the top there, if you see, and then it sort of disappears into a spike and then goes up on the left, and well, there's weird shapes I can get out of it, and that was the idea, to get weird shapes. Let me just turn that red one off as well. So yeah, there's your kind of just bog standard triangle wave. But when you start controlling it with another triangle, I'm getting these sort of patterns. These are almost sort of square waves for a moment. And yeah, I don't know why you would use that in a synthesizer, but it's all about experimentation. So if I actually change one of the waves, let me change the actual wave to a ramp, and then start messing about with its sort of mixers and things, and there. I mean, could that be useful for someone? I don't know. Reverse, do all sorts of things. So depending on the kind of the signal that you throw in here, it's going to make pretty patterns, and pretty patterns in control voltages and things like that is going to make something a little bit different to what you're used to. Anyhow, long story short, there you go, the board is complete. Well, that's the control board, and I can mass make these over and over again. I'm going to make one for a Eurorack, and I'm going to make one for the new big modular as well. So that means now what I've got to do is I've got to make the control board. And I've been finding so many different ins and outs and flip signal over and attenuate and all sorts of things like that, that I'm starting to scribble down what the control board is going to look like. At the moment I've only got 6 potentiometers on here, but I already know I need a couple more to bring the voltages down a little bit to within 5 volts and things like that. Yeah, so there's going to be more potentiometers. So I'm going to now call this a day on this video. This is kind of part 1. I didn't want it to go into 2 lots of video, but that bit's done. That bit's completed. Now I'm going to try and work out all the different ways that you can mangle a voltage and work out how many jack sockets I need, how many switches I need, how many potentiometers I need to make the second board that's going to be the faceplate for all the ins and outs that actually goes onto this little board here. And then I've got to figure out how I'm going to get that little board to sit on the back of that little board and then into a case and things. So yeah, this video ends here, and I hope you click subscribe and see what I do with the rest of this, because it's kind of, I think that looks kind of interesting. Maybe in a synth world, I don't know, I haven't got a clue until it's all actually all put together and I start using the control voltages and things like that. I don't really know how useful this is actually going to be to anybody. But all the schematics and everything, when I've finished, will be all under there somewhere in the video. There'll be links to everything anyway if you want to make one of these yourself. And it's all done really, really easily. It's only TL074s, which are quad op amps. That's it. Nice and cheap and cheerful. A few resistors, a few capacitors. That's basically it. So, right, end of video. Please click subscribe, and hopefully I'm going to have a second one coming up soon where I figure out how sort of big and useful I can try and make this into some sort of module. So all the best. Thanks very much for watching, and watch the next one that comes after this. All the best. Bye bye.